Welcome, kind people. Welcome back to our live streaming. Welcome to the Mathematics in the Modern World. This is your discussant, Engineer Sotero Alnapomuceno Jr. Okay, welcome, guys who loves mathematics. Okay, so this is still a part of our application of algebra, the same as the age problem, the clock problem, the concentration problem, okay, the motion problem, economics problem, and whatever, okay? So this is work and rate problem. So our intended learning outcome is to be exposed and to be acquainted to different types of basic applications of algebra as mentioned previously. Okay, so we have here Ashley and Ricky can complete a job in 7.2 hours. Ricky and Andrew can do the same job in 12 hours. Ashley and Andrew can finish in 9 hours. How long will it take Ashley, Ricky, and Andrew to complete the job working together? Okay, so this is rate or work problem. So before anything else, I'm gonna into the basic concepts of work in relation to energy and in relation to power, right? So in our basic education, I think most probably our physics teacher taught us that work is the energy to capacity to do the task, right? And we can say also energy, the capacity to do work. Okay? So energy is the capacity to do work. So meaning energy and work is equal and has the same unit. Okay? From that statement. Okay, energy is the capacity to do work. Okay, so meaning energy is equals to work. So they have the same unit. Okay, for example, calorie, joules, or any unit of measurements of energy. And then what about power? Is that equal to energy and work? So in order for us to navigate our understanding with the power, then we need to recall the basic practical electricity knowledge. So if we have power is equals to work over time. Okay, so let's say 746 watts is equals to 1 horsepower, right? So 1 horsepower and okay, 746 watts are equal. This is a conversion factor, and this is the unit of energy in terms of electricity. So this means this is the unit of electrical energy specifically. Okay? This is one form of energy, electrical energy. Okay? So 746 watts, it's in the numerator, 746 watts. Okay, for example, if there's no given time, t, in different problems or situations, so we're going to assume that the t is simply equal to 1. Let's have an assumption or basis of calculation that t is equals to 1 second. Okay, because mostly in derivation, we need to let the certain quantity is equal to 1, for example, area. So we need to let that as 1 squared meter. If we're talking about the Newton per square meter, the unit of pressure. So in any occasion, especially if the problems doesn't mention the values of the particular quantity, by default, we're gonna let that quantity as equal to 1 so that it's easy for us to have the derivation equation. So if we let t is equals to 1 is equals to second, so this will become 1, right? So we will say P is equals to work divided by 1. So meaning to say, P is equals to the work. So therefore, the power is also directly proportional to the work. So I could say energy directly proportional to the work, directly proportional to the power. But the only difference is that the power has the time in the denominator. So that is the rate, no, the power rate of that appliance. For example, a refrigerator, okay, air conditioning, okay, things like that. So the power. So we need to say watts per second, like that, no? Or horsepower. Okay, get that point? So therefore, directly proportional with each other. So if I will say I need to carry things, I could also say I need power to carry these things, or I need the energy to carry these things. So in order for me to have work done in carrying the things, I need power and I need also energy. So they are basically equal, but the only difference for this is that power has a different unit compared to the energy and the work. Okay? Things like that. Now we are concentrating here for the work. This is work and rate problem. So meaning to say there's a time. Okay, there's a time in the denominator. Okay, so this kind of problem always talks about how long will it take the job to finish, how long will it take the job to be completed, things like that. Okay, so talking about the rate. So the general or the standardized formula of the work slash rate equation is equals to 1 over T, okay, and this T is the total work to be done by any persons, like that, no? It's equal to 1 over A plus 1 over B plus 1 over C, so on and so forth. So this A, B, and C are the respective time of the person who does the work. Okay? Things like that. Because if this is T, obviously you add these three components. Obviously, each also has its time in the denominator. So this A also is the time for the A person to complete the task. This B is the time for B person to complete the task. C is the time of the person to complete the task. So the denominator are always expressed in time. So whether it's in seconds, in hour, or whatever, as we wish, depending on our problems. Okay? And this is a general formula. And now we're going to start now understanding with this. Right? So based on my basic discussion. Okay? Things like that. So be careful for this because it's always coming out in the examination. Work, energy, and power. Okay? So it's always be coming out in the examination. Okay? So work also has its separate or distinct formula. Work is equals to force times distance, like that, no? Okay? And energy, there's a lot of problem, equation, sorry. For example, kinetic energy, or 1/2 mv squared. Potential energy, mgho. The mass times the acceleration due to gravity times the height or the elevation in vertical position. So because potential energy is an energy at rest, and kinetic energy is energy at motion. The opposite, okay, definition of the potential energy is the kinetic energy. Okay, things like that. Now we've already done the basic concepts, and now we're gonna proceed smoothly how to solve this. Okay, so let's try to determine what is being asked. How long will it take us for Ashley, Ricky, and Andrew to complete the job working together? Okay, so take note with the grammar. working together. So we need to say the total of these three guys, Ashley, Ricky, and Andrew, the total time it takes for them to get the job done. Okay? Things like that. So, solution. Okay? Get the point. So, let A is equal to Ashley. Okay, so this is the first step in mathematics. We always let variables for unknowns, and we're gonna master this all throughout our education or our course of study, because the moment we don't know to let unknowns, then we will be suffering in our course, especially engineering courses loves to have unknowns all the times. Okay, so the basic concept starts there. Okay, so B is Ricky. Okay, and then C is Andrew. So pero why you let A, B, C? It's easy to let the first letter of their name. Okay, example, Ricky R, Andrew A. Because Ashley and Andrew would have the same first letters the same. See, A. So it's better to designate a nomenclature that is distinct with one another. No, it's not the same. Okay, so A, B, C, and this is really the usual unknowns to be catered in algebra or in mathematics. No, A, B, C, capital letters or the small letters A, B, C, or the X, Y, Z, the small letters X, Y, Z, most of the times. Okay, and it's very prevalent. Okay, that unknowns and variables will always be like that. Okay, as you can notice that also. Okay, so how can we do this? We can say by having the concept previously, the 1 over the total time of the persons that does the task, like that. Okay, so we'll say 1 over T subscript A, B, C, like that. Okay, is equal to, okay, 1 over T A plus 1 over TB plus 1 over TC. This is our equation according to this problem. So this is A, the time it, okay, finished by Ashley, the time Ricky will finish the job, and C, the time will Andrew finish the job. Okay, things like that. But the problem here is that the condition, it's not taking individually. As you can see the first sentence, Ashley and Ricky can complete a job in 7.22 hours. So there are two persons to complete the job. It's not individually. So you'll say here as Ashley A, right? So I can say 1 over T A. And then Ricky is B. So plus 1 over TB for Ricky, right? Okay. So the total will be 1 over 1.72. And this is in hours. We don't need to put the unit because it's understood in the final round. We're talking about of time here. So it's not necessary to keep on putting HRS, no, the hours in our solution. Okay, so this is our equation 1. Okay. Equation 2. Okay. Ricky and Andrew, okay, here also, Ricky and Andrew can do the same job in 12 hours. Because guys, this will not be difficult if the problem is stating individually their time. Okay, but the problem here, it takes two persons, no, to have the time in the total job finish. So this is quite a little bit complex, no, actually. Okay, so we have here Ricky B, therefore 1 over TB plus, because B must be Ricky. Andrew is C, so 1 over TC. So the total is 12 hours. So this is 1 over 12. So this is our second equation. You get the point. Okay, done. the third equation. Okay, so third condition, Ashley and Andrew can finish in 9 hours. It's gonna be 1 over Ashley, A, T, A. And then Andrew, C. So 1 over TC. The total of the time they could finish both 9 hours. So 1 over 9. So this is equation 3. Okay? So we have 1 over 7.2. This is 7.10. This is not 1.72, 7.2. So this is usually my mistakes, guys. When I'll take the exam, no? Okay. I know how to solve properly, but the problem is the times I will put the numbers, it will be misplaced, and then too much erasures. These are really more on that negligence only, not in that kind of analysis. No, that's my weakness. I practiced that before to make it clean, no, in my solution. But it will just come out my human nature, no. But at least it was controlled. Okay, but still it will come out also. I cannot stop it, no, because human nature will always coming back, even though how hard you try to stop that habit, it will just come out unexpectedly. You get the point? Oh, but at least we tried our best to change for the particular technique that makes us accurate in our solution. Okay, things like that. So we have three equations now, no? So equation 1, equation 2, equation 3. Okay, be careful also in designating the total hours. Maybe it will be misplaced, no? Things like that. Okay, equation 3. What do you gonna do for this equation 1, 2, and 3? Can we add them directly? No, we cannot add them directly because see, 1 over TA. Okay, so this is not 1 over TA alone. This is with TB. 1 over TB. TB here. There's TC. So it's you cannot add directly. Okay, so 1 over TC. So this is 1 over TA plus 1 over TC. Okay, so there's a confusion no? with other component. How can we do that? Okay, things like so. We're gonna erase this problem because my whiteboard is very small. No, so let's continue the solution. So actually, guys, I'm giving an example which is a little bit difficult. Okay, things like that. Okay, and this is also a trick type of solution I'm gonna teaching you later on, no? Things like that. But I still go through the process, okay? Things like that. So we have here. So 1 over TABC. So okay, continuation of our solution. Okay. So 1 over T subscript ABC. Okay. You get the point? So we have here TB plus, okay, 1 over TB plus 1 over TC. Okay, 1 over TB plus 1 over TC. Okay, this one. But take note, we need to do this in chronological order because our subscript and TABs, actually it doesn't matter. But I need to be precise. I need to be systematized and organized. No, it would mean the same thing, but it's better to go to the systematized way of discussion. So see TAB. So therefore, this is 1 over TA plus 1 over TB first. No, so let's do it chronologically. Okay. Okay. Then next, and this TAB. So therefore, this whole thing is 1 TAB. Okay, the next. Okay, the next coming from 1 TABC. So we can generate after TAB, we can generate BC. Okay, so 1 over TBC because after AB, BC, let's see chronological order. Okay. So this is going to be 1 over TB plus 1 over TC, our second equation. Okay, third. 1 over TABC. Okay, then we gonna BC ni siya, guys. Okay, BC. So therefore C, right? C, and then going back to the first letter A. So this is 1 over TCA. So therefore 1 over TA plus 1 over TC. Because this TCA, okay, this is just multiplication, commutative property. So we can also say 1 over TA plus 1 over TC, or 1 over TC plus 1 over TA. Since we are chronological order, we do first the A instead of C. But actually, it means the same thing also. I don't need to be precise. Okay? These things here, it's okay to be interchanged. Okay? Because this is plus. It doesn't matter at all. You get the point? But I need to discuss in a chronological manner. You get the point? Things like that. So we have now here, no? 1 over TAB, 1 over TBC. So therefore, we can also say also here, 1 over TAC. Okay, things like that. Okay? Now, since we are expressing this 1 over TABC in this manner, this one, and this 1 over TABC in this manner also, and 1 over TABC in this manner also, and equal to each respectively. Okay, so we can automatically add these things out, right? So we will say 1 over TABC is just equals 1 over TAB, right? You get the point? Plus 1 over TBC, okay, plus 1 over TAC. Okay, get the point? Okay, so substitute values now. So 1 over TABC, so 1 over TAB is equals to this. Substitute that here. So 1 over TA. Actually, guys, it looks like complicated to, to follow the steps, but we need to be investigative to do this, no? And keen of eye detail, no? So plus 1 over TBC is here, right? Oh, copy this one. Oh, put bracket, no? In order we will not be confused. TB plus 1 over TC. And then this one, 1 over TAC, carry siya. Okay, 1 bracket again, 1 over TA plus 1 over TC. Ganun. Now, as you can notice here, this is simply an addition of fractions, no? With variables in it. So what is the rule in math if we keep on looking variables and letters? So we need to look for the like terms. Remember this always, forever and ever, amen. When we try to solve mathematics, we'll always look for the like terms so that it could easily be added, it could easily be subtracted, it could easily be divided, and it could easily be multiplied. You get the point? So this is the philosophy in algebra. Okay, like terms. So kindly check the like terms here. So yes, we have 1 over TA. We have also 1 over TA here. 1 over TA plus 1 over TA. What is the answer? Because it's also a little bit confusing. Okay, based on our stat knowledge. Maybe we will say 1 over 2TA. Actually, guys, if we say 1 over TA plus 1 over TA, it's 2 over TA. You need to carry the variables. It's like saying 2x plus 2x is equals to 4x. The moment it will be 1 over 2x plus 1 over 2x. Okay, things like that. Okay, that is 2 over 2x. You get the point? It's not 1 over 4x. This is a little bit confusing, right? Because others will opt to add the denominator. Okay, it's not. It's the numerator because this is fraction. You will say 1 over 2x plus 1 over 2x is equals to 2 over 2x. You just copy the denominator. You will not add the denominator, okay? But if it's not a fraction like this only, 2x plus 2x is equals to 4x. Take the difference, okay? Here also, 1 over TA plus 1 over TA, that is 2 over TA. You got the point? 2 over TA. Sige. 2 over TA. Then go to the component B. So TB also has here the like terms. 2 over TB. Okay. Then TC also have common 1 over TC plus 1 over TC, 2 over TC. Okay, get the point. Things like that. Now, in this manner, be careful also. Okay? Because if you say 2 over TA plus 2 over TB plus 2 over TC, you cannot add also. Because why? The denominator is not the same. So, the rule says if it is a fraction involving variables, you can only add the numerator if and only if the denominators are having the same terms or like terms. In this, TA is not equal to TB. So obviously, you cannot add 2 in the numerator. So you can do the factoring, no? Things like that, because common is 2, right? So we're gonna put this 2 out, no? And then put parentheses like that, no? Okay. And then do the manipulation. Okay. So 2 over TA. Okay. Okay. How can you do that? So you factor 2. So that is 1 over TA. 2A divided by 2. So 1 over TA. Diba? Because multiplication and division are dual with each other. They are partners. So if I try to divide, then you multiply that later on. That will be exactly what we are trying to do, the operation. See? 2 divided by TV. So that is 1 over TB. Okay. Okay. Because when you multiply 1 over TB times 2, it will become this 2 over TB. Okay? Then carry the sign all the time. Be careful. Every time move the sign as is. No, don't forget that one, because if you try to put that directly, it will become multiplication. Okay, so 2 over TC divided by 2, that is 1 over TC, right? Now this is now the expression of the whole thing, 1 over TABC. Now, this one, let's erase this to make it clear. See, we have here the equation previously. 1 over TABC is equals to 1 over TA plus 1 over B plus 1 over TC. The same like terms here, right? Okay, got the point. So if that is the case, there's a 2 here and there's a bracket here. We can also multiply this by 2, this whole thing. So we can see also that 1 over TABC multiply also by 2. Okay? So that it will be having the same expression. When you multiply these components here, you multiply also here. Okay? Things like that. Okay? Now, we go back to the expression now. So therefore, we conclude, and erase this one. Okay? Therefore, we conclude that. Okay? So we conclude that. See, copy this one. Okay? So, okay. So we conclude that 2, 1 over TABC is equals to this one. 1 over TA plus 1 over TB, first component. So 1 over 7.2. So 1 over 7.2. Okay, because this is just telling TAB before, as what I discussed a while ago. Then plus, okay, the TBTC, this one. So 1 over 12. Okay, plus TATC, 1 over 9. Like that. Okay. Now, so TABC, how can you compute this one? This is now we are asking in the problem. This is the time for Ashley, for Andrew, what's the other one? Okay, Andrew and Ricky to complete the task. Okay, TABC. Okay, compute now by algebra in this case. Okay, guys, since I'm not good in having the greatest common factor by trial and error, because trial and error, we need to go from the least number going to the bigger number, things like that. No, in getting the greatest common factor for this. Okay, and in this case, we need to get the least common multiple between the three denominators so that when we divide that, we can get an exact answer. Divisible. A number that is divisible by this, by this, by this. So this is not okay. Greatest common factor. Yes, it's not this common multiple. The least common multiple is the divisible. Okay, because it could be multiplied in common. That's why least common multiple. So the number is small. Okay, see, least common multiple. So from the grammar accuracy, it should be the least number that is divisible by the numbers, no? Okay, or it could be multiplied kasi multiple eh. Okay, get the point, no? Oo. And then it can be also the reverse. It can be divided also. As I told you, division and multiplication are jowa. They are partners. Okay, get the point? Oo. So now, for me, when I was in college, it's easy for me to multiply directly the here and the here and the here and the here like that. And then I tried which gonna have or produce exact answer. But if that is not very exact numbers, if you try to visualize that one, we need to multiply the smaller number to the higher number. That's what I understand. Okay? If there is point something and there's no exact numbers, no, it's not divisible by something. So see, 7.2, it's not good. Okay, right? So we need to use our calculator for this. Okay, so wait for a while. We need to compute, no? So we use calculator because there's a point something. It's not easy to solve basic mathematics if we don't use our scientific calculator, especially if it involves decimal points. Okay? So here, so our greatest common factor, okay, things like that, no? I think we're gonna multiply first the 7.2 times 12, no? Times 12. What is the answer? 7.2 times 12, that is 86.4. Now, if we try 7.2 times 9, okay, so 7.2 times 9 is 64.8. If we try 12 times 9, 12 times 9 is equals to 108, no? So 108. So these are the possibilities, no, of your greatest common factor. 108, okay, 108, 64.8, 86.4. Okay. Now try 108 because from the grammar accuracy, greatest, this is the greatest of the three. So can we divide 108 to 7.2? 108 divided by 7.2. It will give exact number. Okay, here. 108 divided by 12. Yes, exact number also. How about here, 9? 108 divided by 9. So we get also exact. So use this one, greatest common factor, 108. Okay? So in this case, mga palangga, okay, since we need variable here, this ABC is 3 variables or 3 letters. So therefore, we can just say let ABC is equals to X. So that our purpose only to solve for the value easily. Okay? Things like that. So we will just change this to X. Okay, 1 over TX. Diba? O ganon. Things like that. Actually, it's just the same. No? Okay. Now, 2 times 1, 2. Diba? Then over TX. Let's equal this whole thing. 7.2 plus 1 over 12 plus 1 over 9. The technique here, guys, Okay, things like that. The technique here is that you need to multiply this both with 100. Okay, 100. What? GCF 100x, because in algebra, if there's variable, you need also sometimes to consider the variable in getting the GCF, not only the number. Again, if the fractions or anything includes variable, your GCF also will include variables. But if your fractions or whatever expressions doesn't contain variables, then your GCF, obviously, common sense, will not have also variables. Okay? So in this case, 100x, di ba? Ganon. Okay. Or we can say 180x. Because tx man siya. Okay? Things like that. Then, 180x times 2 over tx, no? So, ako yung punta sa kilid-kilid, berta mag-ibog. So, 2 times 180x divided by tx. So, cancel si tx. So, 2 times 100. Let's show this in the side so that it's easy to understand. So, 2 times 108. See? We multiply, but we divide. So, di ba? So, they are opposite, the multiplication and division. Okay, so 216. So 216, so na-cancel ang variable, cancel variable, so no variable at all, is equal to, and this one also, 1 over 7.2 times 100 tx. Okay, so 7.2 times 100 tx, no? Okay, laman. So 108 divided by 7.2. 15tx, no? So 15tx plus 1 over 12 times this one. You are only distributing, huh? Distribution multiplication. Okay. And then 1 over 12 times 100 tx. Okay. So 108 divided by 12. 9. So 9. There's still tx. Tx. Okay, get the point? Ganon. Plus 19. Okay, 1 over 9 times 100 tx. So 108 divided by 9. So we have 12 tx. Okay. Tx plus tx plus tx, you can add a 3, right? So 15 plus 9 plus 12 is equals to 36tx. 36tx and 216. So divide both sides by 36. 36 cancel. So tx is equals to 216 divided by 36. 216 divided by 36, mga palangga, 6 hours. 6 hours. So this is also equal to 1 over TABC. No? So, okay. So the total time is 6 hours. Okay? So it takes 6 hours for Ashley, for Andrew. What's the other one? I erased already. Kimberly. Okay, got the point, no? Okay, to work together. Okay? 6 hours is the answer for the problem. 6 hours. Okay. Now, in our technique in the board examination, okay, you don't have to derive like this all the time. Okay? So, when I was in college, I already memorized how it is being done because it's very easy to detect the way how it is being traced. Okay? So, if the problems will have like that always, pair, and then asking together like that, so it's easy to detect. Okay? So, we memorize directly the technique. No need to derive. This is derivation kasi. You get the point? So, because it will take a longer time for one question, and then there's still 150 questions in the board examination. Okay? Things like that. So, remember, pair mentioning, and then there's a total hours each, and then asking, working together, the 3. This will be the direct technique, direct, memorize, direct solution. Okay, you will see directly by memorization. Okay, you will say 2 times 1 over tx, okay, is equals to 1 over TAB plus 1 over TBC plus 1 over TAC. Okay, and this TX is just ABC. Okay, and this has value, this has value, this has value, because TAB will be the 2 hours finished, TBC 2 hour, the 2 guys finished, AC 2 guys finished. This A, the name of the person, B, the name of that person, C, the name of person. Kanira gid imong memorization, guys. Okay, you get the point? And the only difference, you need to multiply that by 2 here. This, actually, the original kasi 1 over ano kasi yan, 1 over TABC. But since due to the condition, the 2 of them will have total 1. So 1, 2, 1, 2, 1, 2. So you need to multiply the original equation with 2. That's why it's multiplied by 2. But you can also get that also when you try to derive, as what I clearly emphasized a while ago. You get the point? So memorize directly mo yun ani, okay? So that it's easy na lang to solve. Okay, to tell you honestly, this is difficult part of working and rate problem. But I don't believe also this will come out every time because it needs too much, too much analysis. Okay, but for the people who keep on exposing themselves to various types of work and rate problem, so they knew it also. Okay, because most of the times this type of problems are kept on repeating. Okay, I use this because this is not common. The other one is very easy kasi 1 over TAB, 1 over TA plus 1 over TB, and then substitute directly, and then you can get the answer. So there's no challenge. Okay. For example, I will say, Pedro can paint the house in 2 hours. Lisa can paint the house in 3 hours. Okay. How the 2 together can paint the house? So just add directly. You get the point? So that's it. Any questions so far? I will be showing you another example also that includes like twice as faster as Lisa, less than like that. Okay, so actually this is not a problem because it's being taught in our basic education. It's more than blah blah blah. It's less than blah blah blah. Twice as blah blah blah. Twice as less than as blah 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 blah. you need. This is only the translation from words to symbols and mathematical operation, right? For example, okay, this is what I've learned really that I will never forget in my entire life. If you see "is" is equal, if you see plural "are" is equal also. If that is "was," the past tense of is also equal. Where also is equals to equal. So this symbol you need to always supply that in your solution. If there is an English terms linking verbs s, these are all linking verbs in grammar. Okay, are, was, where. There are 4 linking verbs including the past tense. Okay, so always put symbol. Lisa is so equal. Lisa was older than was, so equal. Lisa and Pedro were equal. Okay, thanks, so no problem. Okay, another. We say of. This is multiplication. 36 of 100. So 36 times 100. So the meaning of is multiplication. Gets? Okay. Now, another. Okay. If it says what, and that is simply the unknown x. What 36 of 20? X is equals to 20 times 36. Okay? What 36 of 20 is blah, blah, blah. So you can solve now. Okay? Things like that. And then what else? Less than. 8 less than 9, like that, no? So that is subtraction. More than is plus, less than is minus. But be careful with the minus because the age of Lito is less than Pedro. So you will not put 8 minus x. You will put x minus 8. This is the trick also. If the age of Lito is 3 less than Marie, nga na ba? Okay, get the point, no? So you will never carry the big number first, no? It should be the unknown first minus the number. X minus 7, x minus 3. If talking 7 less than the age of blah blah blah, 3 less than the age of blah blah blah, or 6 less than it paint the blah blah blah. So you will never say 7 minus x, ha? 3 minus 1. Wrong imong answer. You could achieve a negative answer, and during manipulation, it's wrong. So there's no problem in more than, because 8 plus x is also x plus 8. It's just the same commutative property. If you change the placement, it doesn't matter because this is just addition. Subtraction, it's not. Okay. The same also with multiplication. If you x times y, y also times x. But division, never. Division, never. If you say x over y is not equal to y over x. You get the point? So division and subtraction, it's not having commutative property. It's always multiplication and addition. The placement will be rumbled. It's okay. Okay? I hope it's so. This is very basic in mathematics, right? In the law of exponents, the 7 laws of exponent. Okay? What's that? Product rule. Let's review. Power rule, product of the product rule, product of the power rule, the quotient rule, okay, the product rule, and then the exponent rule, the negative exponent rule, okay, the identity exponent rule, and the inverse exponent rule. Okay, so I hope you understand what's this each, because by the time you encountered expressions, you can apply that there. Okay? Things like that. Any questions so far? I hope you like this video. Bye bye. God bless everybody. See you later. Thank you so much for watching for this work and rate and time probably. Bye bye. God bless everybody. See you later.